Welcome back to another awesome video with Damos in the class. Today's aim is prime and composite numbers. A prime number is a positive whole number with only two factors, one and itself. For example, 7 is a prime number. The only factors of 7 are 1 and 7. For example, you see 1 times 7 equals 7. What is a composite number? A composite number has more factors than just 1 and itself. For example, 15 is a composite number. It has factors 1, 3, 5, and 15. The examples are 3 times 5 equals 15 and 1 times 15 equals 15. Our first example, is 2 a prime number? Yes or no? So the first thing we want to do to figure this out is we want to figure out how can we make the number 2. How can we make the number 2, Jamin?
1 times 2.
Exactly. 1 times 2 equals 2. Is there another way that we can make 2?
No.
All right. So therefore, it's only one way to make the number 2. So it is yes, it is a prime number. Great job. All right. So for our next one, is 10 a prime number? Yes or no? So remember, the first thing we're going to do is figure out how can we make the number 10. What ways can we make the number 10?
1 times 10.
1 times 10?
And 5 times 2.
And 5 times 2. Great job. So it's more than one way that we were able to make 10, right?
Mm-hmm.
So then that means it is a composite number. So is it a prime number?
No.
Exactly. Great job. So for the next one, is 4 a prime number? Yes or no? So how can we make 4?
1 times 4.
1 times 4? Mm-hmm.
And 2 times 2.
Good job. 2 times 2. So, answer the question. Is it yes or is it no a prime number?
Yes. It's a composite number. We would have did more than 1 time.
Exactly. Composite numbers, don't forget, means we can make the number in more than one way other than 1 and itself. So it is no, it is not a prime number. Great job. All right, so for the next one, is 7 a prime number? Yes or no?
Yes.
Why is it a prime number?
Because 1 times 7 equals 7.
And that's the only way that we can make it. That's why it's a prime number. Great job.
Yeah.
1 times 7 equals 7. And that is the only way that we can make 7. So yes, it is a prime number. Great job. For the next one, is 5 a prime or composite number? So how do we figure it out? First, we try to make our equations to see how to make the number, right?
Yeah.
The number is 5. How can we make 5?
1 times 5.
Exactly. 1 times 5 equals 5. Is there any other way we can make 5?
No.
So then the answer is prime or composite?
Prime.
Exactly. Great job. Prime is our answer. You getting it? Now the next one. Is 6 a prime or composite number? What's the first thing we do?
We write an equation. 1 times 6 equals 6.
Mm-hmm.
And then 2 times 3 equals 6.
Great job. 2 times 3 equals 6.
And that means it's a composite.
It is exactly. Great job. It is a composite number. Great job. So what I really like about practicing prime and composite is it helps you to brush up on your multiplication. Great job. All right. So now for our next one. Is 19 a prime or composite? How do we make 19?
1 times 19.
1 times 19. Is there any other way we can make 19?
No.
Nope. So there you go. So what's going to be the answer? Prime or composite?
Prime.
Great job. Prime number it is. Great job. All right. So is 14 a prime or composite number? First thing we do?
1 times 14.
All right.
2 times 7.
Great job. 2 times 7. Any other way to make 14?
No.
All right, but it's more than one, right?
Yes, that is a composite.
Great job. Composite, composite. You are getting this. You are mastering it. So moving right along. Is 11 a prime or composite? First thing we do.
1 times 11.
1 times 11. Why I say the first thing we do is write out the equations, because you don't want to have to think about this thing. You need to see for yourself, is it or is it not? And this way, you're practicing your multiplication facts, because then you have to think, what two numbers multiplied get me the number I'm looking for? So we think, what two numbers do we have to multiply to get to 11? You said 1 times 11. Is there anything else?
No.
Great job. So now what?
It is a prime number.
There we go. That makes it a prime number. Prime time, baby. 1 time, baby. Prime time, baby. You got it. All right. So now we have is 18. A prime or composite number?
First thing I have to do is write 1 times 18.
That's right. 1 times 18. What else do we need? Or do we need anything else? Is that it? You tell me.
That's it.
That's it? It's the only way we can make 18?
3 times 6.
All right. 3 times 6. That gets you 18. That the only way?
Yeah.
Yeah? Think. This is where the practice of the multiplication come in at. Let's go. Let's get it. How else can we make 18? All right, so there's one more way to make 18. Did you forget about 9 times 2? That gives us 18 too. See? So you got to practice your multiplication. So is it a prime or is it composite?
Composite.
All right. Why? Because we got 3 different ways that we can make 18. So it is a composite number. Great job. All right. So for the next one, is 16 a prime or composite number? What are we writing?
1 times 16.
All right.
Yeah, 1 times 16 we get 16.
Mm-hmm.
And 2 times 8.
Great job. 2 times 8. Is there another way?
Four times 4.
All right. 4 times 4. Taking you a little minute means you need to practice. If they're not coming out quick, means you need to practice. So what is it going to be? Prime or composite?
Composite.
Great job. Composite. All right. So moving on, we're going to go up the chain. Is 30 a prime or composite number?
So we need to do 1 times 30.
Mm-hmm. Is there any other way to get to 30? Or is that the only way?
Yeah.
So, this what I'm going to do for you. I'm going to let you know, anytime the number ends with a 0, we can always split it in half.
Like 1 times 3 and you add 0.
Well, no, that's how you get to 30, 10 times 30. So we actually got 2 times 15. Right? But what about the smaller ones that you should know? Like 6 times 5. All right? This is why it's so important to practice. So you could either do those 3 ways. Let me think. Is that the only ways? Yeah, that's about the only ways to get to 30. 3 ways. Okay? So is it prime or is it composite?
Composite.
Great job. But also, like I was saying, if it ends in a 0, you can always split it in half. So while you're trying to figure this out, this is just us doing it and we sharing. However, if you're doing this by yourself and you're on a quiz, test, homework, whatever, so you have the number 30, just throw it in the house and work it out. How many groups of 2 can we get out of 3?
Get 1 group.
That's right. So we put our 2 underneath here because 1 times 2 is 2, right?
Mm-hmm.
We do our subtraction. 3 times 2, we have how much left over?
1.
All right. We bring down our 0. That leaves us with 10. How many groups of 2 can we get out of 10?
We get 5 groups.
All right. 5 times 2 is how much?
10.
And there we go with our 15. So how else you could try to figure it out is you can just always divide each number by whatever you think. You can divide it by 3. If we divide it by 3, that's going to get us 10. Right? So as a matter of fact, I just realized that we didn't do that one. 10 times 3 gets you 30. Ain't that what you said?
Yeah.
Oh, you did say something like that. See, I'm so sorry. So there's 4 ways to do it. And this is how you can not miss any. Because as the numbers get bigger, it's not as easy to remember them off the top of your head. And as I get older, it's not easy for me to remember off the top of my head. However, showing you this method helps everyone brush up, right? No matter how old you are. So now we got the same 30, right? Like I said, we add a 2. All we have to do is put that 30 in the house, put a 3 on the outside. We get one group, right? 1 times 3 is 3. Nothing left. We bring down a 0. We add a 0 here. 0 times 3 is 0, and we have nothing left. That got us our 10 times 3. Right?
Mm-hmm.
All right. So you can try that with 4. Now, what the answer and the key to this is, we can't have any remainders. We have to have a full group in order for it to be an actual factor. So let me find some room. And we're going to move on. So we got 2. So let's see. I'm just going to let y'all see how this thing works. So we got, these are the ones we say it is, right? So let's see, does 4 work? 4 into 30. Right? 7 times, well, we can't go into the 3, right? That's the first thing we look at, the first number.
Mm-hmm.
It's too big. 4 is too big. So now we look at the whole 30, right?
Mm-hmm.
So how many groups of 4 can we get out of 30? To get as close as we can, if not to 30. 4 times what? 4 times 2 is what?
4 times 2 equals 8.
4 times 3?
4 times 3 equals 12.
4 times 4?
16.
4 times 5?
20.
4 times 6?
24
4 times 7?
equals 28.
So 28 is going to be the closest that we can get. So we put out 7. We get out 28. But the problem with this is, right, we have 2 left. We cannot have a remainder. So 4 doesn't work. So you don't have to worry about 4. 4 doesn't work. So we move on to 5, right?
Mm-hmm.
We put out 30 on the outside of the house. How many groups of 5 can we get out of 3? Can't get none, right?
Yeah.
So we look at the whole 30. How many groups of 5 does it take to get, if not 30, but closest? So 5 times 2 is how much?
5 times 2 equals 10.
5 times 3?
15.
5 times 4?
20.
5 times 5?
Equals 25.
5 times 6?
Equals 5 times 6 equals 30.
There we go. So we get our groups, right? So we already know that that's 30. So if we did 6 divided by, it's just going to get us the opposite, which is 5, right?
Mm-hmm.
We already know 7 don't go into 30 because we're only going to be able to do 4 groups to get us to 28. If we do 8, we could try 8. We could try 8 and see what that does. But the thing is, we cannot have any remainders, right? So now we have an 8. We have the 30 outside the house. Well, excuse me, we have the 30 in the house, 8 on the outside. So 8 is too big for 3, right?
Mm-hmm.
So we have to look at the whole 30. So how many groups of 8 does it take to get us to 30 or as closest to 30? What's 8 times 2?
8 times 2 equals 16.
8 times 3?
24.
8 times 4?
8 times 4 equals 20. 8 times 4 equals 32.
Exactly. So we passed the number, right?
Mm-hmm.
So we only could have did 3 times, which would have got us 24. But like we said, we cannot have a leftover. 6 is a leftover. So 8 wouldn't work, right? And 9 definitely doesn't work, right?
Mm-hmm.
So you can do this all the way until you get to the 10 because you want to make sure you cover everybody. This is how you know all your factors. So 9 is too big for the 3. We look at the 30. 9 times 2 is what?
No, 9 times 2 equals 18.
Exactly. 9 times 3?
9 times 3 equals 27.
There we go. So 3 is going to get us the closest. But what's the problem? Again, we're going to have a leftover, yes?
Yeah.
We can't have none of those. So we already know that if we put the 30 inside the house, yes?
Yeah.
We put the 10 on the outside. You can look at it one of two ways. You can cross out your 0 in your mind right?
Mm-hmm.
And how many groups of 1 do we get out of 3?
We get 3.
Exactly. So we get our 3, right?
Mm-hmm.
But because we're doing 10, it's really this.
Yeah.
Yes. So that's how you get the answer to that. But in your mind, you think of that. And then you just put it over top of the 10s. I hope that didn't confuse anybody. I will go over long division again. But I'm just trying to show y'all something by using division. Now, you can keep on doing this. We already have the 10. So you can go 11. All the way till you get to the 15. Because what you're going to realize is that's the most you can get. 15 and 2. 2, when you split it in half, whatever those two numbers are, that's going to be the highest factor, and this is going to be your lowest factor. So this is the highest, highest factor, or you can consider multiple of 30, and that's going to be your lowest. And these are the ones in between. So really, those are those 4, and we get a composite for 30. Got it?
Yeah.
I hope so, or we getting it. As long as we moving closer. Great job. Getting it?
Yeah.
All right. Like to hear that. Great job. Along, we have 43. Is that a prime or composite number? Now, if you know your multiplication, this is why I say it helps sharpen you up. Because you should already know, have you ever seen 43 as your answer? So 1 times 43 is the way to get it, right? Is there any other way, as long as anybody been doing multiplication, that they seen 43 come up as the answer? Let's just check. So, how can we say this? Let's just look at, we're going to divide, like I told you. If you don't know, always divide, right? So we divide. We can't have any leftovers. Remember that. So now 2 is small enough to go into 4, right? So how many groups of 2 do we get? To go into 4, how many groups of 2?
2 groups. 2 times 2 is 4.
All right. So we don't write our 0. We just bring down our 3. How many groups of 2 can we get out of 3?
You get 1 group.
All right. So 1 times 2 is going to give you 2. And that's going to leave us with 1 left. That's why that doesn't work. We cannot have a remainder. It has to evenly go in. And that leaves us with 1 over. So no, that doesn't do it. So now another way you can look at this is there anything that you know that can get you close to 42? Like what kind of multiplication, 2 numbers that you could do to get you close to 42 being the answer? 43 being the answer. Sorry guys, I just split.
8 times, 5 times 8.
5 times 8. All right, so 5 times 8 gets you 40, right? That's not close enough. You want to be to where you can see a 43. So how about 6 times 7, right? Since I slipped it up. It's 42. Those are the only 2 to get you as close as you can. Long story short, 43 is a prime number. Another way you can always tell, 3 at the end of mostly any number is going to be prime. Why? Because 3 is prime. So you have an even number and you have an odd number. The odd number being 3. 3 is a prime number. The only way you can make 3 is 1 times itself, which is 1 times 3. So with that being said, 43 is a prime number. All right? I hope that's not confusing, but we're going to look at some other ones like 53, 63. What's up for 63? It's 63, except for 63, because 63 you can do by 9. There's a few exceptions, but it works with a lot of them. And again, if you know your multiplication, then you know when multiplying, you have not seen 43 as an answer, going all the way up to 1 to 12. So that's why if you practice your multiplication, it will help you use process elimination much more quickly. But great job. Now, is 45 a prime or composite? 45. Do we know any ways that we can multiply to get 45? What's the first way?
1 times 45.
All right. What's the next way? Or is there a next way?
No.
It ends in 5. So you should already know it's a multiple of 5. So that means 5 times something gives you 45. 5 times what? Do your 5 times tables.
Yeah, 5 times 8 equals 40.
5 times 8 equals 40. That's correct. But we need 45.
5 times 9.
Get you 45. Great job. So, again, this makes you understand that where you rusty at in your multiplication and what you need to be practicing. So, is there anything else that we can get? I'm going to say we can maybe do a 3. So, we have the 45. We divide that by 3. We can get one group out of the 4, right? So, we put that 1. 1 times 3 is how much?
3.
All right. And we have 1 left over. We bring our 5 down. How many groups of 3 can we get out of 15?
We get 5 groups.
Great job.
So the biggest 5 times 3 is 15.
There you go. So 5 times 3 is 15. Nothing left. So we get 15 times 3 gets us 45. So those are the 3 ways that we can make 45. So is it prime or is it composite?
Composite.
There we go. Great job. All right. You are getting the hang of this. Okay, so now we have another one. It's going to make you probably think, because we're moving up from the easy ones. But you just got to start thinking in your mind, even if you haven't done the multiplication, what can I divide this by to get even groups, right? So we have 39. We know we can always do 1 times 39 to get us to 39, correct? All right, so that's the first one we write. But since you may not know another one, right? We're going to put 39 in the house, right? Now, this is an odd number, so we cannot divide odd numbers. This is an odd number, so we cannot divide them by 2. They do not divide evenly, right? Only even numbers divide evenly by 2. That's why it works for 0. So, when we have an odd number, we have to divide by an odd number. So, looking at this number, what number do you think we should divide by?
3.
Exactly. Why will we do that? 2 reasons. We see a 3 here. That's our first reason, right? The second reason is, can't we do 3 times 3 to get 9?
Yeah.
So we should already know that 3 is going to be a good match for this number, okay? So now, if we have 3 and we divide it into 3, how many groups do we get?
1 group.
All right.
Yeah, because if it's like 2 divided by 2, we get 1.
Exactly. So 1 times 3 is?
3 times 3 equals?
1 times 3 is?
3.
We have nothing left. We do not write our 0. We bring down our 9. How many groups of 3 does it take to get to 9?
3 groups.
Exactly. So we have a 3 again. 3 times 3 is 9. And we have nothing left. So 13 times 3 is going to give you 39. So with that being said, those are the 2 ways. And it's going to be what? Prime or composite?
Composite.
There we go. Great job. All right, so is 79 a prime or composite?
First thing we need to do is 1 times 79.
Yep, 1 times 79 equals 79. And is there any other way that you could think of? So, another way to look at this. 79, we know 7 is prime.
Yeah.
So that's what's going to probably most likely get it, the fact that this is going to be a prime number. Why? Because it has a prime number already in it. So when it's already mixed with a prime number, it can't become a composite number. 7, there's nothing to divide into that equally. Even leaving stuff over, there's nothing that's going to end with 9, because none of your multiples multiplied by anything gets you 19, 29, 39. So whatever's the leftover, it still won't work. So it's definitely a prime. But you can take your time and divide against that to see for yourself. Does anything work out? For time's sake, I'm just going to let you know 79 is a prime number. I'm also going to add in a prime and composite worksheet at the end of this video, so please stay tuned so you can get you a copy. Great job. All right, so now we have 49. Is 49 prime or composite? Is 49 prime or composite? So first we have 1 times 49. And what other way, or is there another way that we can make 49?
Yes.
What?
7 times 7.
There we go. 7 times 7 equals 49. So is our answer prime or composite?
Composite.
There we go. Great job. Those are the only two ways to make it. Great job. All right. All right, so is 21 a prime or composite? What do we write?
1 times 21.
All right. Is there any other way that we can make 21?
Yes.
How? You right on the year.
1 times 21.
Mm-hmm. What else?
Three
Mm-hmm.
3 times.
3 times what?
3 times 7.
There we go. 3 times 7. I know it's going to get you sooner or later. And it's going to make you think. Composite or prime?
Composite.
There we go. Great job. All right, so now we have 63. Is that prime or composite? So 1 times 63 gives us our 63. Is there any other way we can make 63?
Yes. 8 times.
Is it 8?
9 times.
9 times what?
9 times 4.
9 times what?
Times 7.
Exactly. Great job. 9 times 7 is 63. Is there another way we can make 63? You got to look at these numbers. You got a 6 and a 3. We can get a group of 6 out of both of them, right? I mean, a group of 3 out of both of them. 63. Right?
Yeah.
So you got 3. How many groups of 3 can you get out of 6?
2 groups.
There we go. 2 times 3 is 6. We got nothing left over. We bring down our 3. How many groups of 3 can we get out of 3?
We get 1.
There we go. So 21 times 3 will get you 63. And I believe that'll probably be it. So it's going to be prime or composite.
And we composite.
Great job. Doing awesome. All right, so now we have 71. Is that prime or is that composite?
So we have 1 times 7.
What?
71.
Okay, 71. So, again, there's a cheat sheet always. A 7 is prime. The 1 is not either prime nor, that's the thing about it. 1 is not neither prime nor composite. It's just 1. Neither is 0. So that's a fact that you need to know. That I'm also going to add in at the end of the video just for you to have as a study guide. But I should have been put that up there, guys. That 1 and 0 are neither nor prime nor composite. So, like I said, I will add in at the end, but I just want to quickly tell you that numbers 0 and 1 are neither prime nor composite. All even numbers except for 2 are composite numbers, and every whole number greater than 1 is either prime or composite. That's just something that you want to remember. All right, moving on. All right, so we are almost to the end. We got maybe 1-2 more problems to go, but we are doing fabulous. Great job for hanging in there. And so is 93 prime or composite?
So 1 times 93.
Mm-hmm. And what else? Didn't we notice something from 39? This is the same thing, just backwards. What do we see? 93, 39. What numbers do we know that we can get out of there?
A 9.
Well, not really necessarily the 9, but we could definitely get 3s.
Yes.
Right? So, remember, 93 in the house, 3 on the outside. How many groups of 3 does it take to get us to 9?
It takes us 3 groups.
There we go. So 3 times 3 is 9, leaving nothing left over. We don't write our 0. We bring down our 3. And how many groups of 3 can we get out of 3?
We get 1.
Exactly. So therefore, we get 31 times 3 will get you a whole 93. Yep. Looks about right to me. So, is it prime or composite?
Composite.
There we go. Great job. Just don't forget, if you could pull groups out of it, then you can make it's composite. That's just another way to say it. Great job. All right, guys. So, for our final and last problem for today's lesson is 103 prime or composite.
So I have to do 1 times 103.
Equals 103. And what do you think the answer is? Prime or composite?
Prime.
Great job. Why do you think it's prime?
Because we can only do one way.
We only can give me a high five. That is the exact answer you're supposed to say. We only can do it one time, y'all. And another way you could know, this is why I keep telling you, look at these numbers. We got 103. One is a prime. Well, not really. Neither nor a prime or composite. However, you need more than itself, more than one to make another number. And our other number is a 3, which is prime. So therefore, you are correct, Mundo. The answer is prime. I hope you guys really understand what's going on. If not, to help add, I will be adding in a whole chart that's going to be labeled where you can see what number is prime, what number is composite, so you can get this thing down pat. But either way, still, if you hung on to the end, you did an awesome job. Thank you for hanging in with us. And I'm going to make sure I add that in here at the end of this clip. Thanks, guys. You've been awesome. Right? You did a great job. High five again. I'm proud of you. Mm-hmm. As promised, prime and composite number chart. This will help you master factorization. Everyone, so that comes to the end of this video, and I really hope that you got something out of it. And always know, it's not what you don't know, but what you're willing to learn. And until the next time, catch you there.